Here are the objectives of WEBSTER's method. First is to define WEBSTER's method, explain the concept of WEBSTER's method, and to solve problems using WEBSTER's method.
So, Webster's method, proposed by Daniel Webster in 1830s, allocates seats by rounding quotas to the nearest integer, rounding up for the 0.5 or higher and down for the less than 0.5. For example, 6.78 rounds to the 7. Webster's method divides the population by modified divisor, rounding result up or down based on standard rules in a just divisor until the correct number of seats are located, balancing upward and downward rounding.
So in the definition of terms, we have three examples to give. The first one is apportionment. So it refers how seats in a legislative body are located based on population data. The method ensures that the distributions of seats is proportional to the population sizes of different groups or regions. The second one is divisor method. So it works by dividing the population of each state or group by a common divisor, then rounding the result to assign seats. So the divisor may be adjusted if necessary to ensure the total number of allocated seats matches the available seats. And the last one is the standard divisor. So standard divisor ensures that each seat represents roughly the same number of people. For example, if the total population is 1 million and there are 100 seats, the standard divisor would be 10,000, meaning each seat should ideally represent 10,000 people.
Alright, now let's move on to steps and procedure. So in the Webster's method, there are also steps and procedure of how you were able to know how to solve a certain problem. So there are 5 steps or procedures that you have to know in answering or solving a problem. So the first one is you have to find the standard divisor. You have to use the standard divisor as the first modified divisor. And the second one, you have to divide each state population by the modified divisor to get the modified quota. And the third one, you have to round each modified quota to the nearest integer or round off using conventional rounding rules. And in the fourth one, you have to find the sum of the rounded quotas. The fifth one, the last one, if the sum is the same as the number of seats to be apportioned, you are done. But if the sum is too big, you have to pick a new modified divisor that is larger than B. But if the sum is too small, you have to pick a new divisor that is smaller than B. You have to repeat these 2 steps through 5 until the correct number of seats are proportional.
So here is an example of problem for the Webster's method. So a university is composed of 4 schools. There are 350 new computers to be apportioned among the 4 schools according to their respective enrollments. The enrollment in each school is given in the following table. Find the standard divisor and standard quotient of each school. So in the table below, there are humanities having 1,250 enrollment, for business having 985 enrollment, education having 1,420 enrollment, and science and math having 1,595 enrollment.
So to find the divisor, we need to divide the total number of enrollment and the total number of new computers. So the result would be 15. So for this, 1,250 divided by 15 is equals to 83.33. So the same method is applied to the remaining schools, which is the business, education, and science and math. So for business, we have 65.66. And for education, we have 94.66. And lastly, for science and math, we have 106.33. Since the Webster's method needs to be rounded off, so the final answer would be 83, 66, 95, and 106, with a total number of 350, which is proportion to the allocated new computers.
A university is allocating 350 new computers to 4 schools based on their student attendance. The overall enrollment for all schools is 5,250, and the standard divisor calculated by dividing the total enrollment by the number of computers. This divisor means that one computer will be assigned to every 15 students to decide how many computers each school receives. The university computes a standard quotient by dividing each school's enrollment by the divisor. The humanities department has a quotient of 83.33, whereas business has 65.66, education has 94.66, and science and math has 106.33. These quotients result in a final allocation of 83 computers for humanities, 67 for business, 95 for education, and 106 for science and mathematics.
So, in conclusion, the Webster method, also known as the major fractions method, is a mathematical procedure used to apportion seats in our representative body based on population or vote counts. It works by assigning seats using a rounding method that allocates the remaining seats to the candidates or parties with the largest fractional parts of their quotas. Unlike some other apportionment methods, such as the Jefferson or Hamilton methods, which can favor larger or smaller states or parties, Webster Webster's method aims to balance representation more evenly by rounding quotas to the nearest whole number. This method is often considered more fair because it minimizes the bias toward either large or small entities, providing a more proportional representation. However, its fairness depends on the specific context of use, as no single method perfectly resolves all apportionment issues.